In this video, I will be talking about the first topic, differential equations and solutions. So first, we need to know what are differential equations. So recall that an equation is something equals to something else. And what it means, differential, that means derivative. So a differential equation is just an equation that contains derivative. And because of that, we have the definition. A differential equation is just an equation that contains derivative. That throughout the course, we will see several different types of differential equations, and then we will learn how to solve differential equations. So before talking about differential equations in more detail, we'll look at an example from physics. Later on, we'll learn several other examples of differential equation, but for now, look at this. So say we drop a water balloon from a top a, a building. And we want to describe how the water balloon moves or drops, meaning that we want to describe the motion of the balloon. So let me draw a picture here. Say we have at time, say t0, the balloon at the top of the building, and a certain time t later on, and the balloon is somewhere else. So how do we describe the motion? We need to use Newton's second law. To do that, we will set up a few things. So first of all, the balloon is dropping down. So we're going to choose a positive direction. It's going down. This is the positive. So anything that going downward is positive, and anything else that upward will be negative. And then we need to look at the forces acting on the balloon at each time t. So we always have gravity, going downward, and I will denote that by F sub g, and we know it's the m times g, where m is the mass of the balloon and g is a gravitational acceleration. And what other forces can we consider here? There may be others, but for now, let's just assume we have another one. There's one other one, that is the air resistance. denoted by F sub D for drag force. Now there are several ways to model the air resistance, and here we're going to assume the following. That air resistance is proportional to the velocity. So what does means proportional? Proportional means that velocity is bigger, then air resistance is bigger. If velocity is smaller, air resistance is smaller. That is, the F of D is a constant times velocity. But remember that air resistance is upward, which is negative, so we need to put a minus sign in front. And the gamma is called the proportional constant. And v is the velocity. So let me put in the picture here. That's mass gamma times v. So now we have the formulas for all the forces acting on the balloon. Now let's use Newton's second law. Which says that the total of all the forces is m times a, where m is again the mass of the balloon and a is acceleration. So let's add up two forces over there. We have gravity and the air resistance. We have m times g and then minus gamma times v equal to m times a. But what is a? In terms of velocity, that's just derivative, dv dt. So we may rewrite the equation as mg minus gamma times v equals to m times dv dt. Or let's divide everything by m. We will have this gamma g minus gamma over mv equals to dv dt. And this is a differential equation. Because we have an equation, equality, something equal to something else, together with a derivative, dv dt, and that's why we have a differential equation. In this equation, the unknown is the velocity v, which is a function of time. And the t is the variable or independent variable. And this is always the case for a differential equation. We have an unknown, which is a function, and then independent variable. Now let's look at other example of differential equations. In fact, you can write down any equation with derivative, then we have a differential equation. And here I'm gonna write out randomly something like this, say dy dx plus 3x equal to y squared. Uh, then it's a differential equation because we have the equality here together with the derivative. Here the unknown is what? Is y, because that is a function we are taking the derivative, right? Dy dx, unknown y, and the independent variable is x. We're taking the derivative in the variable x. That's why the notation dy dx. This differential equation is said to be of order 1, first order, because in the differential equation here we only see first derivative. So first derivative. Now let's look at another example. Say we have something like this: y triple prime minus 3 y prime plus 2y equals to t squared. Again, we have derivative, and this time in this equation we use the prime notation for derivative. We have two derivatives here. This is a differential equation, and the unknown is y, and what is the independent variable? We are taking derivative with respect to which variable? If we just look at the left hand side, then we don't really see the variable. But on the right hand side, we have t, and that gives us a clue that t is the independent variable. And the derivative, say y prime, is actually dy dt, and then y triple prime is the derivative 3 times with respect to t. The order of this differential equation is order 3 because we have the highest derivative in the differential equation is triple prime. So in general, the order of a differential equation is the highest derivative you see in the differential equation. Of course, you can come up with other differential equations, and later on we will see a lot more. Now, whenever we have an equation, we need to talk about solutions. And the same thing here with differential equation. And what do we mean by solution of a differential equation? A solution of a differential equation is a function y such that if we plug y and its derivative into the equation, we obtain a true identity for all values of the independent variable. So notice that a solution must be a function. This is quite different from regular equation in colloquial algebra. Here, any solution should be a function y, meaning that we should have something like y equal to an expression in terms of the dependent variable. We have a function so that if we take y and then its derivative and put them in the equation, we obtain a true identity for all values of the variable. So to see what's really going on, let's look at a few examples. For example, let us consider the equation, the following equation: x times y prime minus y equal to x squared. Again, this is a differential equation because we have an equation together with the derivative here. The unknown is y, and the independent variable is x. So we want to check, is the function, say y equals to 3x plus x squared, a solution? Well, to do that, we need to compute derivative, because first derivative appears in the equation right there, and then we also have the function y. So let us compute the derivative, which is 3 plus 2x. And now we need to plug into the equation and see if we have a true identity. I have x times the first derivative y prime, and y prime is given right here. I need to plug in 3 plus 2x minus y, and y is given as 3x plus x squared. So I need to plug in, and remember, when I have several terms in y and minus sign, I need to put parentheses around to make sure later on I have to distribute the minus sign. And then we want to check if this is a true identity for all values of x. Let's distribute. We have 3x plus 2x squared and minus 3x minus x squared. Is it the same as x squared? If algebra correctly, then we have x squared on the left side equal to x squared on the right side, and this is a true identity. So because of this, the conclusion, y equals to 3x plus x squared is a solution to the given equation. So in order to verify whether a function is a solution or not, we need to take the derivative. And in order to take the derivative, you need to have the skills from calculus 1. You will need to know differentiation rules, especially product, quotient, and rules. Now here is another example. We consider the same equation as in the previous example. And the question is y equals to the x plus 3x squared a solution? You may pause the video and check for yourself. But here is the answer. So as before, we're going to take the derivative, get 1 plus 6x, and then we plug into the equation. X times the derivative, which is 1 plus 6x, minus y, which is x, plus 3x squared. And we want to know, is it the same as x squared? Distributing x plus 6x squared minus x minus 3x squared is the same as x squared. And we have to simplify in like terms. We have on the left side 3x squared equals the right side x squared. This is not a true identity. For all x. So the conclusion for these problems, I want you to always write out the conclusion. Y equals to x plus 3x squared is not a solution. Now let's look at another example. Consider the differential equation. Y double prime minus 2y prime plus 5y equals to 0. As before, we know that this is a differential equation because it's an equation having derivatives. Actually, we have two derivatives, y prime and y double prime. So the unknown is y. But what is the independent variable? Well, here we are using the prime notation, so we don't really see explicitly what the independent variable, and the equation doesn't contain any clue to tell us. So actually, we should assume, say in this example, the independent variable is t. It could be x as well, if we want to use x as the independent variable in this case. But the problem is to verify that y equal to e to the t times sine of 2t is a solution. You should pause the video and check it for yourself that this given function is a solution. This is a very good example because you will need to practice product rule and the chain rule for derivative. Furthermore, in this example, we need two derivatives, y prime and y double prime. And after you have checked it for yourself, you can continue watching. So we compute the first derivative using the product rule. We have e to the t times psi t. This is the product of two functions. So by the product rule, we have the derivative of the first one, which is derivative e to the t. We get the same thing, e to the t times sine of 2t plus e to the t times the derivative of sine 2t, which is cosine 2t. But don't forget the chain rule. We have 2 there. We may rewrite e to the t sine 2t plus 2 e to the t cosine of 2t. Now next, compute second derivative by using the chain rule again. E to the t sine 2t plus e to the t cosine 2t 2. The first give us these two by the chain rule. And for the second piece, we have another chain rule, 2 e to t cosine 2t, 2 e to t. For the derivative cosine, we have negative sine 2t. And don't forget chain rule. Now let us combine like terms. So we have here e to the t sine 2t and this e to the t sine 2t but with the minus sign. We have one factor of one term e to the t sine 2t and this is negative 4 terms. Together have negative 3 e to the t sine 2t. And for cosine of e to the t cosine 2t, right here we have twice Over here we also have twice, so together we have 4 times e to the t cosine of 2t. Now let us plug into the equation. Let's go back to the equation right here. We need to have second derivative minus twice first derivative and then plus 5 times the function. Begin with second derivative minus 3 e to the t sine of 2t plus 4 e to the t cosine of 2t. This is my second derivative. I need to minus twice the first derivative, which is over here, e to the t sine 2t plus 2 e to the t cosine 2t, and at the end I need to plus 5 times the function, which is e to the t sine 2t, and we want to verify that the same as 0. And let's just do the algebra. Distribute minus 2 in and rewrite minus 3 e to the t sine 2t plus 4 e to the t cosine 2t minus 2 e to the t sine 2t minus 4 e to the t cosine 2t, and lastly we have plus 5 times e to the t sine of 2t is that equal to 0. If we look at like term, we see that e to t sine 2t cancel out, and the rest 4 e to t cosine t also cancel out with this. And what we get is 0 equal to 0, which is the true identity. So we need to write down the conclusion. Y equal to e to the t sine 2t is a solution to the given equation. And this is the end of topic of the first video recording. For topic 1, we also have the second part, and there will be the second video for that part.